MillWrite now has two different ways for doing crosshatching, and it can project the crosshatching onto a 3D surface. I'll show you how to crosshatch this particular shape. To begin with, we need a polyline of the boundary to show MillWrite where the crosshatching should be. The man who did the crosshatching had already drawn the boundary in another CAD system and exported it as a DXF file, so we'll use MillWrite to import that DXF file. By the way, if you keep DXF files in a particular folder, then go to the Setup page, click the Defaults tab, and specify that folder so that MillWrite knows where to look for them. Now let's import the DXF file. You might already have a user button set to import a DXF drawing, but if you have never used your user buttons, you can find the import function by clicking the File button at the upper left corner and then select the option to import a DXF, job, NC, or XYZ file, and then pick the first option to import the DXF file as editable geometry. Now we specify the DXF file by clicking the File data field, and the DXF files appear along the right side of the screen. I'll pick this one. I'll set the cam operation to pocket, although I'll have to adjust it afterwards, so it doesn't matter whether I do it now or later. I don't need to identify nesting or reordering because there's only one item in the drawing. I should not have to set the Z values to 0 because they already should be. The next four data fields don't apply because there's only one item in the drawing. I want the items joined together and there are no dimensions, so that can be ignored also. The newest option is to unblock and ungroup the blocks and groupings. I will set this to allow the blocks so that you can see what happens. I now click the OK button. As you can see, there is a dashed box around the polyline, and when you let the mouse hover over that box, the information about it appears on the right side of the screen and shows that it is a block. Blocks and groupings are a nuisance because they require you to unblock and ungroup them in order to alter the tool parameters or to edit the geometry. You can unblock it by clicking the right mouse button over the block and then picking the option to unblock it, or you can click the Edit button, select the Blocks option, and then unblock every block. After the blocks have been unblocked, they become geometry, but the blocks still exist in the job in case you want them. To get one of them into the drawing, click the Draw button, and then select Blocks, and then select Internal Blocks. This gives you a list of the blocks in that particular DXF file. Now when we let the mouse hover over the polyline, it shows as a regular polyline. So let's set it to be crosshatched. You can set the default pocketing option for the entire drawing at the Setup page under the CNC tab. However, to crosshatch only one item in the drawing, you don't have to bother. Instead, click on the Tool tab and then click the Finishing tool. This provides the option of specifying the pocketing option for only this particular geometry. There are two options for crosshatching. One is to leave the crosshatching lines separate, which creates a lot of rapid moves. And the other option is to join the crosshatching lines to keep the tool down and reduce machining time. This is most useful if you are also going to cut along the boundary to clean the edge. I will pick the option to join the crosshatching lines and set the crosshatch angle to 60 degrees. I'll specify a row spacing of 0.5 inches. I'll select the option to cut the edge of the boundary so that the tool cleans the path along the boundary. The type of tool doesn't affect the NC program. It's only for giving you a more accurate 3D model. The two options are flat and tapered. If you're using a ball end mill, just pretend that it's tapered. I will now switch to the 3D view page and then the 3D model option. And if I click the Draw Slow button, you can see that the tool is remaining down as it does the cross-hatching. And when it's finished, it goes around the edge in order to clean it. Now to show how to do cross-hatching on a 3D surface. This piece of wood appears flat, but it has a slight curve to it. The man who created it did it with a hand file. Then he put the piece of wood on a CNC machine to digitize it, and he created a DXF file of the digitized path. That digitized path is a three-dimensional polyline that zigzags back and forth over the shape. To use that digitized path, click the File button and then the option to import a DXF file, but this time select the option to create a 3D surface from digitized paths. If you use this option frequently, you could set one of the user buttons to it. To do that, click one of the blank buttons and then type the word digitize, and the cursor will jump to Surface from Digitized Path. Pick that option. Then click the option to make a surface from a digitized path and select the zigzag digitized path. MillWrite will try to figure out what the grid spacing of the digitizer was, but if MillWrite makes a mistake, enter it yourself. In this case, MillWrite figured it out correctly, so all we have to do now is click the OK button. The man who digitized that piece of wood ensured that the center of the wood was on X0, Y0, and when he created the boundary for the cross-hatching, he put the center of that at X0, Y0 also, and therefore both of these DXF files align perfectly. If you click the little square with the two arrows, you can switch to a 3D view, and you can see that the surface has a slight curve to it. I'll switch back to 2D by clicking the arrows again. The boundary for the cross-hatching is on top of the surface, so MillWrite will project it onto that surface. I will now switch to the 3D view page, and rotating the toolpath shows that it is now cutting in 3 dimensions. The 3D model uses the shape of the tool. In some cases, the model looks best with a texture, and in other cases, it looks better when showing the deeper areas as a darker color. Since this particular 3D shape has a very subtle curve, it can be difficult to see in a video that the cross-hatching is actually following the 3D shape. So I'll stretch the shape in the Z-axis to give it a more obvious and extreme three-dimensional shape. Now it's easier to see that the cross-hatching is following a 3D shape. There are some situations when you want an item to cut into the surface rather than be projected onto it. To let MillWrite know whether you want an item to cut the surface, click the Pocketing Options data field near the bottom of the Tool tab. Then click the option to disable projections onto surfaces. Now when I switch to the 3D view page, the cross-hatching is flat, and it is cutting into the surface rather than following it.